Several years ago, the company that I run, which specializes in medical education and neurology, was doing a strategic planning session, and we raised the question of how effective our educational activities really were, and whether or not there was something that we could do to improve the impact of our education on diagnostic error. The area of neurology where we do business, the disease states that where we specialize have a very high rate of diagnostic error and very long diagnostic pipelines. So we started to look around, and we came to realize that not only was the rate of misdiagnosis very high in the category of neurology where we specialized, but across neurology, the rate of misdiagnosis was unacceptably high. It's 40% across all neurologic diseases. And that when we really dug into the issue, we began to see that it wasn't just neurology. That misdiagnosis or diagnostic error is the single greatest reason for a malpractice claim. And data supports that the rate of misdiagnosis in the United States has not changed since 1960. In fact, there are some studies that illustrate that the rate of misdiagnosis today is consistent with 1923. And that is in spite of an industry that spends $3 billion a year and over $26 billion being invested in improving medicine through education since 1998. Houston, we have a problem. So our organization began to dig into a little bit further. And what we discovered was that there is an element to an information design element that is the problem. The first piece of information regarding the factors that limit the effectiveness of CME, continuing medical education, is the fact associated with the nature of decision making. Human beings make decisions on the basis of one or two pathways. The first pathway, type 1 decision-making, recognition prime decision-making, cognitive bias or heuristic decision-making, accounts for 90% of decisions that are made during the course of any human being's day. 90%. 10% of human thinking is tied to a Bayesian, statistical, considered sober, fact-driven model. So the first issue that we had in medical education was just the nature of the education, the information design of the education to begin with. Because 90% of the behavior that we're looking to change is driven by recognition prime decision making. Yet 90% of the education we provide is targeted at the rational choice model that accounts for only 10% of decisions. So why is there a gap in medicine between what physicians think they do and what they really do? It's because there's a gap between implicit behavior and explicit knowledge. The next piece of information that became clear to us and instrumental in helping us redesign our strategy is, again, associated with the nature of cognitive error or diagnostic error. 75% of errors that are made in diagnosis are tied to recognition prime decision making. There is evidence, there are multiple studies now that are published in multiple domains that illustrate that breakdowns in decision making, not the absence of adequate knowledge and not the absence of adequate data or information, the nature of decision making, how the data is perceived, is responsible for 75% of the error. So we took a look at that and we asked ourselves, okay, well, why would this be the case? Why would there be such a high percentage of error associated with diagnosis, and why isn't the educational model we're employing changing that? The next piece of information that we started to consider as contributing to this problem is the fact that there's an open loop education structure in medical education. And what that means is that information is pushed out to clinicians, but performance is never measured. And the same thing applies to the diagnostic process. Clinicians walk into the exam room, they go through their day diagnosing people, but there is no reasonable methodology by which they receive feedback on the effectiveness of their decisions. There is no systems structure that will help them receive the data that they need in order to understand how to improve their performance. And human beings learn by that type of information. It's the importance of prediction errors, that you only learn when your brain realizes that what you're doing isn't working any longer. And so clinicians aren't being provided with this information in a meaningful way. Generally, a doctor only finds out that they made a mistake when there's an adverse event or a malpractice subpoena arrives. So this open feedback contributes to this problem and is a part of the challenge associated with appropriate information design in medical education. And that leads to the next part of the problem, that open loop, that lack of feedback leads to overconfidence. Overconfidence in and of itself is a problem, but it's particularly problematic when you allow clinicians to make the decision about their own educational needs. So if a doctor is not receiving appropriate feedback, to let them know that their behavior is suboptimal, they cannot possibly choose in a meaningful way activities that will help them improve the behavior that they don't even realize is a problem. So the nature and structure of self-selection and the whole model for CME becomes an issue of information design when you're looking specifically to drive certain behavior change. Which then takes it one step further. That if you look at the neuroscience of adult education, if you look at how we learn and why we learn, you will see that there is this concept called long-term potentiation, which would require about 45 minutes to explain in and of itself. But long-term potentiation basically boils down to the information that's presented on this slide. We are loyal to the ideas that we have because they have worked for us in the past. We will use our experience from prior engagement as a manner by which to determine what information that is around us is currently relevant. And we will have that prior experience impede change because we don't like new information. Our brain wants to continue to employ the existing models, and therefore we will look to anchor into what we already know and then find data to support what we know now, rather than have our brain or allow our brain to completely restructure a neural network. So, if we think we know what we know, unless information is provided to us in a meaningful way, we will discount it and our behavior will not change. So now you have another problem in the medical education model where clinicians who do not have an adequate or a reasonable assessment of their own performance engage in medical education activities, and if the evidence is not compelling enough for them to believe that their brain to believe that behavior change needs to occur, the education that's actually designed to drive change will instead reinforce existing knowledge. It's quite a problem. But neuroscience has an answer. And that answer is cognitive disequilibrium. As I presented before, prediction errors are incredibly important. The dopamine neurons that cast out predictions and then wait for feedback are exactly how we can leverage a system, how we can utilize information design to change a learner's engagement with the educational data. Attention and memory are linked. You remember what you pay attention to, and emotion drives attention. That aha moment, that oh my God moment, that rush of adrenaline helps implant new information in your brain. And the more confused you are, the more emotional you are in engagement with the situation or with new knowledge, the more likely you are to remember it. If you run into a mountain lion in the forest, trust me, your brain does not want to forget that terror. If you are a clinician that's just experienced an adverse event, your brain will not forget. So the idea here then, in order to improve medical education, is to create a system where learners have the opportunity to make mistakes, have the opportunity to engage in a learning environment that opens up the possibility for their attention to be focused on known deficiencies in their own performance. Our organization calls that learning experience clinical diagnostic theater. It is the idea or the philosophy of simulation-based formative assessment. A clinician comes to a learning experience. They are presented with a patient that looks real in an environment that is as confounding as they would encounter in their clinical practice. They move through the simulation. They're given the opportunity to make a diagnosis, and then on the basis of what they did when they were in this online environment, they are then provided with information, a new way of looking at their performance, which then opens the door for them to be able to consume new information in order to improve behavior that they couldn't improve before. This is human-centered information design. It is currently demonstrating that it is possible to create in an online environment exactly the same sort of mistakes that a clinician would make in practice, which thereby offers the opportunity to completely reinvent how clinicians engage with medical education.